So students, we will start the chapter States of Matter. Look all the things around you. Most of them are solid, the tables, walls, cars, trees, books and food. These are counted solid. Some such as lemon, water, milk and orange juice are liquid. We know these types of liquid, these are solids. Okay, you probably cannot see any gases, but they are there too in a fizzy drink, a light bulb, the fumes from car and the oxygen you breathe, and also in the balloons. Okay, in many of the bottle there is also gases. In light bulb there are argon gas and other, we can say, gases which give the different colors, and the fumes from the car, and also the many of the also gases present in the atmosphere, and the main gas, that is oxygen, which we can breathe. In this chapter, we will learn about the three states of matter: solid, liquid, gas, how matter change state, expansion and contraction of matter, reversible and irreversible changes, matters and particles. Any substance that has mass and occupies space is called matter. The space taken up by the matter is called its volume. Any substance, for example, this is book and it has some mass and it occupies the space, so this is also a matter. The space taken up by the matter is called its volume. And any space according to the length, breadth, height, means three sides should be contained: its length, breadth and height, so it's called its volume. Okay, means space. In space we count length, breadth and height of particular matter, and which is occupy any matter, then it's called is space or volume. All the matter is made up of extremely small particle which we can't see. We know that if I have this pencil made up of graphite, and the graphite is the form of carbon, and carbon is also a small particle, and so this pencil is made up of the graphite and it's made up of the carbon, smallest particle, but we can't see the graphite. Okay, we just seen it in under the microscope. Okay, so in most matter these particles are called particles. In most matter we call these particles as particles. A particle can be defined as the smallest part of substance that has all the properties of substance. Means if I have this pencil, okay, and from this substance this pencil is made, and this pencil having all the particular properties of that particular substance. Means again I will define a particle can be defined as the smallest part of substance that has all the properties of the substance. Means if the pencil is making of the graphite, and graphite having the same property as that of the pencil, or we can say the pencil having the same property as that of the graphite, so we can say each sugar particle will have the properties of sugar. Means if we have a sugar, then each particle from the sugar is made, then these particles having the same property as like that of the sugar. Okay, you will see the solids particles, liquid particles and the gaseous particles. The arrangement of the particle molecule, their movement gives the each state of matter its distinct property. Means according to their particle arrangement in solid, in liquid, in gases, these distinguish them in their different properties. Okay, now we will study about their arrangement. Now table 4.1 show the particle arrangement, movement in solid, liquid, gaseous substance. Arrangement of the particle. First, in solid, the particles are close together and arranged in a regular pattern. For example, wood, stone, pencil, computer. You will see in the solids the particles are very close to each other. Okay, for example, I have a pencil, wood, different things, pencil, these are all counted in the solids because particles are very close to each other and having the regular pattern. That's why it's solid. After that, in liquid, the particles are less closely packed and arranged randomly. Example, water, juice, milk, oil. You will see the particle having space inside them. That's why they're having some randomly packed. That's, for example, like water, juice, milk and oil. These are all count in liquids. After that, we'll talk about the gases. The particles are far apart and have a very random arrangement. You will see one particle is here, another is here. They having the very much space in between them. That's why they have very random arrangement. Also in liquid, there is a random arrangement, and there is very much random arrangement between the particles, like example oxygen, carbon dioxide, nitrogen. Okay, random means disorder means they have not their proper arrangement. After that, movement of the particles vibrate about a fixed position because they are very close to each other and the force of attraction between them very strong. That's why they are vibrate due to some temperature, due to some other reason in their particular position. They don't move from one place to another place. Move around each other means they have some space inside them. That's why they move around each other. Move quickly in all direction because they have very much space in between them. That's why they move very fast and in all direction. You also see that when we have any gas in any bottle and when we open the bottle, the gas easily escape from the bottle, and we also smell some particular gas because the arrangement of these particles are random and having very much space inside or among them. After that, their properties like solids, hard and rigid, they have a definite shape and volumes. They can't be flow and cannot be compressed. We know due to the very much force of attraction between their particles, they are solids and they have definite shape and definite volume. Okay, we can't easily compress them because we have to make a lot of force among on them. After that, liquid, they flow and take up the shape of the container in which they are poured. Though they have a definite volume and they don't have a definite shape, liquid can be compressed a little. And we can see that if we have a jug and if we have another container, the liquid will take the shape of that particular container in which they are kept. Okay, but they have a definite volume. Volume will not be changed, but they don't have a definite shape because they take up the shape of that container in which they are kept. Liquid can be compressed a little. We can compress the little liquid a little as comparison to solid because they have some space inside their particles. After that, we talk about the gases. They neither have a definite shape nor have definite volume. They are highly compressible, means the gases don't have the definite shape or no definite volume, and they are highly compressible because the space between their particle is very large. That's why they will not having the particular shape, not having the particular volume, and we can easily or compress the gases as comparison to solid and liquid. After that, why the particles are close, very close to each other, they attract each other strongly and can't move away. This is the question you have to thinking in your mind. The particles are less closely packed than in solid. The attraction between the particle is lesser and they can move around each other. The particles are very loosely packed and the force of attraction between them is very weak and they are free to move around in every direction. Means here will said that why the particles are very close to each other, because they have very much strong force among them between their particles, but here they are loosely packed and the force of attraction between the particle is lesser as compared to solid. That's why they can move around each other. But in the gases, they are very much loosely packed because the space inside the particles very much. You will see in the gases, they have very much space from one particle to another particle. That's why the force of attraction between them is very weak and they can move freely around in every direction. After that, changing state of matter. Okay, how we can change the solid into liquid or liquid into gas, or we also reverse liquid into gas or liquid into solids. Now we will study it. Matter can change from one state to another by heating or cooling. We will know that we easily change the state of particular matter by heating or cooling. The most common example of this, water. We all know that water is the best example for this particular changing the states of matter. Take out a tray of ice cube from a freezer. Ice cubes are water in its solid state and leave it outside for some time. Okay, now you will take the ice cube from the freezer and you will kept outside these ice cubes. You will see the ice will melt. These ice cube will melt and change into the water. So we easily change the state of that particular matter. We change the solid into liquid. This ice cubes will melt to form the liquid state of water. On heating this water in open pan, we will notice the water changing to vapor and vanishing into the air. And after that, when we have the liquid, so when we heat the particular liquid in a water pan, this change into the vapors. Okay, means now it change into the gas. First of all, we change the solid ice cube into the liquid. After that, when we heat the liquid, it changes into gas. Now we changes the three state of the matter: solid to liquid and liquid to gases. It is the heat transfer in matter that cause change of state. Means the state of the particular matter will change due to the heat transfer in a matter. Understand the phenomenon of changing state of matter with reference to heat transfer and the movement particle. Here you will see here that how these particles will change from one state to another state, or how these matter will change from one state to another state. You will see this is solids particle held in a fixed pattern but vibrate, because they are vibrate due to some room temperature, due to some another conditions. Now when we melt this will change into the liquid. Best example is water. After that, particle packed close together in a random fashion, free to move, because in liquid there is some little space between the particles. After that, when we evaporate, this change into the gaseous state, and particle widely separated and move at a great speed. Okay, here this two arrows indication means, you will see why we don't use the single arrow. These two arrow, that it is a reversible reaction, means from gas to liquid we will go, from liquid to solid we go. As in the starting we will come from solid to liquid, and after that we go liquid to gas. In the same way we will go back, means we can reverse the reaction. Like if we take the example of water. Okay, so also by doing condensing or liquefying, we will change the gas into the liquid bag. And if we solidified the liquid by kept the water in the freezer, we get the solids. And if we go direct solid into gas, this process is called sublimation or subliming. Okay, so this is the process, and we will discuss in the next lecture these melting and freezing and vaporization, that how we will change the state of matter through the different process.